Today we're talking about dilations. If you remember, we've talked about transformations before. Translation was a transformation. Translation where we move the object to the right or left and up or down. Remember moving it. Then we did reflection where you reflected over the x-axis and changed the y-coordinate, or reflected over the y-axis and changed the x-coordinate. We've done that. Now we're going to do dilation. What is that? Dilation, it's just a transformation that enlarges or reduces a figure by a scale factor. We've talked about scale factor before, where 1 inch on the model is 2 inches or 5 inches or 20 inches on the actual. All we're going to do is we're going to use that in transformation. Okay, we're going to make an object larger, we're going to make an object smaller. You need to write this down. Alright, so what this says is that this figure, this polygon, JKMN, is graphed here, and J's at 2,4, K's at 2,6, M's at 8,6, and N's at 8,2. Your job is the homework. What the homework's going to ask you is to graph the dilation, and it has a scale factor of 1/2. Really, all that means is we're going to take each coordinate. So let's do J first. No. You're going to make it half. So I'm going to take the first coordinate J. J's at 2,4. I'm going to times each of the coordinates of J by 1/2. So I'm going to take 2 times 1/2, and I'm going to take 4 times 1/2. That's going to give me J prime. J prime is part of the image. The image is the new one. So what is 1/2 of 2? 1. What's 1/2 of 4? 2. So J prime is now going to be at 1, 2. So go ahead and graph that. Graph 1, 2 on your graph. And that's all you do for each one. So for K prime, I'm going to take 2 times 1/2 and 6 times 1/2. What's 1/2 of 2? What's 1/2 of 6? So I'm going to graph K prime at 1, 3. 1, 3. M prime, I'm going to take 8 times 1/2 and 6 times 1/2. I times each coordinate by the scale factor. That's all I'm doing. So what's 1/2 of 8? 4. What's 1/2 of 6?
3.
So we graph M prime at 4, 3. Do the same thing for N prime. What's 1/2 of 8? 4. What's 1/2 of 2?
1.
So graph of that 4, 1. Then finish your graph. Draw it together and see if it looks like the other object. What I've done here, okay, this is this 1/2 of it. This is with a scale factor of 1/2. Does what I've drawn look close enough to this? Yes, it does. All right. This is just optional. This is what I put on here. Normally, I would be able to side it up, but I can't do it with this. With this out. But it fits right there. This looks like this. It's just smaller, which is fine. Okay, it's a scale factor 1/2, meaning 1 inch on this or 1 space on this is 2 on this. And can I see that? This is from 3 to 2. How far is that? 1. How far is 4 to 6? 2. This is from 1 to 4. 3. So guess how far this is? 6. It's twice as much. Alright, this one, you might see something like this, where it says a triangle has vertices, which just means the edges, the corners, has the vertices A at 1, -2, B 0, 2, and C -2, -1. Find the coordinates after a dilation with a scale factor of 2. So this is what you see on your homework, this part. What you need to do is you need to graph the original and the image, the new one, on the graph papers in your homework. Sometimes they'll draw that graph already for you, but I want you to draw both of them. One, so you can compare and see, did I do it right? Does that make sense? The other reason, just it gives you something to start out with. All right, so you kind of have a base of what the image is going to look like. So I've graphed the first one, graphed the original. Now what we're going to do, find the coordinates after dilation with scale factor of 2. All we do is we take every coordinate, the x and y coordinate of A, B, and C, and we times it with 2. So for A is at 1, negative 2, so I'm going to times 1 by 2, and I'm going to take negative 2 times 2 to give me A prime. What is 1 times 2?
2.
What is 2 times negative 2?
Negative 4.
Negative 4. So A prime is at 2, negative 4. Let's graph that. Go to 2 on the x and negative 4 on the y. That should be A prime. Then we do that for B. B's at 0, 2. So I take 0 times 2 and 2 times 2 to get B prime. What is 0 times 2?
0.
What is 2 times 2?
4.
So B prime is at 0 on the x and 4 on the y right there. Then you just do the same thing with C. C is at negative 2, negative 1. So I take negative 2 times 2 and get what? Negative 4. I take negative 1 times 2 and get. So C prime is going to be at negative 4, negative 2. You graph that, negative 4 on the x and negative 2 on the y. Gives me that. Try to connect the dots. Is this a triangle?
Yep.
Does it look like it's twice the size as the original?
Yep.
Yes, it does. So that's all I do. I take the dilation and I times that by every coordinate, the x and y coordinate. Any questions? You need to write this down. All right, so these are just the rules when it comes to scale factor, dilation with scale factor of k. Anytime I talk about k, that's just the scale factor. Instead of saying scale factor all the time, we're going to call it k. That's the variable for the scale factor, k. You need to know these 3 rules. In enlargement, if k is greater than 1, it gets bigger if the scale factor k is bigger than 1. It's a reduction if the scale factor, or the k, is less than 1. And it stays the same as the original figure if k is equal to 1. We can prove that by looking back at the last 2 examples. The first example had a k of a half, a scale factor of a half. What happened to the image? What happened?
Made it smaller.
It made it smaller. K was less than 1, so it was a reduction. The last example we did, the k was 2. What happened to it?
We made it bigger.
It made it bigger. So it's an enlargement if k is bigger than 1. Everybody understand? So you know automatically what it's going to look like based on just looking at the k. If it's less than 1, it's going to be smaller. So if you draw something that ends up being bigger than the original, that's why I was hinting at why you should always draw the original on your graph. Then you know it's wrong if k was less than 1. But if it's smaller, and that's what it should be, then you know you did it right. If k is bigger than 1, like let's say 2, and you draw something smaller, you know you did it wrong. All right? So that's why you always draw the original and the image together, so you can compare. They stay the same. If you get the exact same and k is 1, then you did it right. Yeah, Beagle. This says find the scale factor, and nothing else is cut off. So what you need to do is write this down and draw the 2 x's. All right, so you're supposed to find the scale factor. To do that, you use this right here. And it's taking the length of the dilation over the length of the original. That's all you do. The length of the dilation over the length of the original. This example, it says the dilation is the larger one. Right, make sure you're paying attention because that's going to matter in your scale factor. If you use the smaller one as dilation, you're going to get the wrong answer. So let's say the dilation, the image, the new one, is the larger one. What we do is we find the length of it on the x-axis. So here it's at 9, and here it's at 3. And what we do is we subtract those x coordinates. It doesn't matter what the y coordinates are, we just subtract the farthest x coordinates. And we find the length of this object. Which, what is 9 minus 3? 6. And you can look, there are 6 spaces in between there, right?
Yeah.
Then what you do is you find the length of the original. We're going to say the original was a small one. So we're going from 3 to 1. What is 3 minus 1? 2. And you can see there are two spaces in between the longest part of this x, right? So you take the length of the dilation, and you take the length on the original, and you divide those. What's 6 divided by 2? 3. Now, sometimes you'll get a fraction. If we were making the dilation a smaller one, this would be a fraction. It'd be fine. But this is 3 over 1, and we can say the dilation, the k, the scale factor, is 3. And we can look. This was 2 spaces. Guess how long this one is? 6. Twice, or 3 times as long. Any questions? Here's your homework assignment.